Prediction of clinical trial results using compressed sensing with artificial intelligence will be discussed. Contents include overview, compressive sensing, data, empirical sample data, results and conclusion. The compressive sensing with an original modification, which could obtain an outcome by predicting unknown data including the observed data, to clinical trials. We demonstrate the prediction of the result of phase 3 clinical trial in terms of p-values of survival analysis. The formula for compressive sensing is shown here. I won't go into details, but compressive sensing is one of the methods to predict larger unknown data from a small number of already known data. A single calculation yields a single predictive data. The final result is predicted by repeating the calculation to obtain a probability distribution of the result. For data, we need the date of the randomization and the date of the event. I will explain why we need the date. Consider the data of 5 cases. On the left, there is a date, which corresponds to a prospective study. On the right is the case where the number of days is known but the date is unknown, which corresponds to a retrospective study. Importantly, the direction of the analysis progression is different. On the left, we will know whether the case is censored or not as time passes. On the right, you will know whether the case is censored or not as the order of the cases. Look at the dotted red line in the left panel. On this date, there are 3 cases of survival and 0 cases of death. This condition does not appear in the data on the right panel. In other words, the data is different between the left and the right. Since the data is different, the results must be different. Therefore, information with date data is necessary for prediction. Let's consider an example of a clinical study in which groups A and B that require a final total of 300 cases. Assume that this study has already been completely finished. We know the date of random enrollment for each case, the date of the event, the number of days in between these dates, and the final result of censoring or non-censoring. Will we be able to correctly predict the end result when we are in the middle of the process? When 1,307 days have passed since the beginning, which corresponds to 43% of the planned sample size of the cases, the Kaplan-Meier curve is shown. The p-value of the log-rank test between the two groups was 0.04781139. This is greater than the value of 0.00063, which is usually used for interim analysis. In this case, the decision was made to stop this clinical study. Now, would the same be true for our method? When 1,307 days have passed from the beginning, 43% of the planned number of cases, what are the predicted results of our method? This is the distribution of p-values for the log-rank test predicted by our method. This time, this test was repeated 58,564 times. The minimum, maximum, median values, and 95% confidence interval, etc. are shown. Now, the actual final p-value was 0.00223. If we draw this value into the distribution of our predicted p-value, it will be at the position of the arrow in the figure below. It seems to be a good prediction. The probability that the predicted p-value is less than 0.05 is 100%. The possibility of a significant difference in the final results is probably correct, since more than 95% of the predicted p-values were less than 0.05. The possibility of a significant difference in the final result is probably correct. Both the predicted and actual p-values were less than 0.05. The actual p-value was not different from the predicted p-value. We got good predictions with our method. At 43% of the planned cases, in the conventional method, it was decided that the study should be stopped. However, with our method, it was thought that this clinical study should be continued because we expected to see a significant difference in the result. This method would also be helpful in establishing futility benchmarks in phase 2 and 3 trials. Date for randomization and event data required. The references are listed. Thank you for your attention. The speech was referred by translated with www.dbell.com/translator. Free version.